Okay, we're going to look at implementing nFozzy Roth rubber dampeners. In my opinion, the most significant update you can make to visual pinball physics. And people will say physics are subjective and everybody likes their own thing, but I mean, nFozzy did quantitative research to show that this is how a ball behaves, or more accurately, how a ball behaves, compared to any variation you can just simply make in visual pinball. So I can't play a game that doesn't have this, and I think once you recognize it in a game, you won't be able to either. It is that significant. So I have Schizo's Monster Bash, and I'm grabbing a large and a small mesh from there. They're on layer 11. I'm going to copy and paste that to the game we're going to update. In this case, it's Taxi. And I chose Taxi because the way the rubbers are set up is pretty representative of how rubbers are set up in most games, and it's really well built. I mean, there's some games that somebody tried something goofy, or somebody just did not make things the way they actually are in a pinball machine, and maybe that needs to be rebuilt instead of just getting a physics update. But for most tables, this is how rubbers are implemented. We can look at a couple variations at the end if we want. But so on layer 11, I'm going to put those meshes from the other game, because those are going to come and be the things that the ball collides against. And then just a really quick overview, so stick with me here, or fast forward if you know the editor pretty well, but I think these are important things to point out. These elements are locked. You can unlock them by selecting and then unlocking, and then you can move them. But if they're locked, you can't make changes to them except over in the options editor. So, all right, so there's that, and then there's collections, and we need to understand how collections work. Collections are table elements. They can be different types of table elements. They don't need to all be the same, but they help us categorize things and also call things to those elements. So, for example, in A plastics, this is a sound call in the script. Anything in A plastics that gets hit plays a specific sound. So if we go into that, we see that these 6 elements on the table are in this directory and are calling that sound when they get hit, because fire events for this collection is on. If I turn that off, nothing would happen when the script called these. So this needs to be on if something happens in the game with these elements. The other thing that can be helpful and can be frustrating is this group elements together box. So if I turn that on and I click one of the elements in that collection, they all get selected. And this is helpful because I can go make global changes now to the elasticity or whatever. But it can be sort of painful if you go to move one element. I'll unlock these so I can show you. So I think I'm just going to move this element, and I grab it. I don't see that something else is selected elsewhere, maybe off screen, and I start moving it, and I say, oh, I want this here. And then I've sort of messed up a whole bunch of other things on my game. So it's just something to be aware of. If something's in a collection and this is checked, and you need to leave it checked for whatever reason, you can shift click and just get that one element and work with it. But be careful, because if you grab it again, you grabbed everything. So it's just something to be aware of. And then the other thing to be aware of when you're changing things for elements like this, if let's say 2 of the things in this group aren't visible and the other ones are, if I select everything in this group, this box shows it as not visible. Okay, it's just because there are different variables, but it looks like none of them are visible. It's not true. So if you're changing something to visible or invisible, you want to click it and then unclick it. Now none of them are visible. So anyway, that's how that works. And you kind of need to know how those work, because we use collections a lot to make this happen. All right, so what we're doing now is we're going to take all the rubber elements that the ball hits in the game. We're going to make them not collidable anymore, just visual. So you only see them, the ball never touches them. And we're going to replace them with something that works much better. So what I want to do is I want to go to the select element tool, and I'm going to sort by type, and I'm going to find all of the rubbers. There they are. Okay, so I'm going to select them. There they are. I'm going to right click. There's 45 elements up here. You can say it's 45. And they all happen to be rubber because we still have these options here. If these options aren't here, it means something in the collection that you grabbed or something that you also have highlighted. Like, for example, if I highlighted this gate as well, then we don't really have any options. But if we get rid of that gate, everything's a rubber, and we could make changes to a lot more of these things. So if I right-click all the things that are highlighted right now, all these rubbers, I want to move these to a different layer so it's easier to find them. I'm going to move them to layer 10. Because now I can go to layer 10 and just see all the elements I need to work with. They're still highlighted, so I want to turn them off. They're no longer collidable. The ball will just pass right through them now. That's exactly what I want. And I'm going to turn on layer 11 too, which is where I place these. So the basic idea here is that the ball interacts differently where there are posts than where there are not posts. And so we are going to put these elements where there are posts. Still acts like rubber, but is not the same. So I'm just going to take this and I'm going to copy. Well, let's do physics materials first. So one really convenient way to manage your physics is to use materials. It's easier to change all of the physics settings for a certain type of element at once this way. There it is. So we're going to pull this in. And this is all the Z-call stuff from the Monster Bash game. I guess should have just shown you how to do this. So you would just go here. These are all the physics. You would export those to a .mat file, and then you would import them here. All right, so I've got them. These are going to set our physics. So I can grab this, and look, it already has rubber posts because that was the name of it in Monster Bash, so that's cool. But as you update the whole table, not just the rubbers, you're going to use that. So, look, we've got this metal wall right here. The physics material is no longer going to be the one that was set in the game. We're just going to go ahead and set it to metal with some fall off. So you're going to do that for everything, but not now. That's not what this tutorial is. Back to business. Okay. So that's there. And then we need a collection to put these in. The collection is going to be called dposts. And we need to make sure that fire events for this collection is selected because we need some things to happen in the game when a ball hits one. So, all right, there we go. So we got that, and we're just going to go around and copy and paste everywhere where there's a post. And right now we're going to do that based on what these rubbers look like, and then later we are going to go in and just double check that there aren't some places where there are posts that we don't see from here. You can fast forward for a minute. I'm not going to edit this video. You know what? Screw it. I'm just going to do this much of it for now. And then for pins, you would do this, and these have a different material, rubber pegs instead of rubber posts, but they still get put in this dampening collection. So okay. So what I could do is just turn on 11 and grab all of these, and then That's checked because some of them are in dpost, not all of them are. So again, I mean, this is dumb editor stuff, but it's what we have. So now they're all in there. And you can double check that by doing this. And you can see, you could also remove one or add one like that. So, all right, so now all of these are collidable. And the part that we need to change now is to put a wall across here to handle this part of the physics collision. So I'm just going to create a wall, try to make it kind of seamless so there isn't a lip or anything weird that the ball would bounce off of. There are ways to do this, I think, faster and easier in Blender if you're comfortable in Blender. But if you want to do this all in the editor, this is what you're going to do. And then this doesn't go into dpost, doesn't have a dampener, but it does need a rubber physics material. And in this case, that's the rubber band. Okay. You want the hit event to be on for this. If you want a sound to play when the rubber band gets hit. I don't, because it doesn't really make much sound when the rubber band gets hit. These, however, you're going to make sure your hit threshold is at 0.5. And these, they're already in dpost, but I also want to hear it when they get hit. So I'm also going to add them to a rubber posts, because that's the directory where the sound is being called. So anyway, and that's basically it. Let me show you just a quick variation. And that's where sometimes across a stretched rubber band, you'll see a post, like right here. All right, so here we have a rubber band that is stretched like this, and so we would put this here and this here. But if we look, there's another post here, and so the ball is going to behave here the same as it does over here. So don't forget to be thorough and do something like that. And we're actually going to bring that all the way out to the edge of there. And really, there's very little like rubber band material here. I would actually, if this were my project and I were going to put a lot of time into it, I would create a third physics material to be sort of a midway between a post and a stretched rubber band, and put it in between these. But that's a little bit more of a nuanced thing. And so those things are kind of at your discretion as you get into this and want to do this more accurately. There's also like post sleeves, and I don't think there are any in this game. I guess I should have looked. That's the tall sort of cylinder looking things. And so if you had those elements, you would size it to the size of whatever that rubber is. You would just do that using scale, not along Z because that's up and down, but your X and Y. So say it needed to be smaller, you could just change it like that. And then that specifically, you would create a collection called D sleeves and put it in that. And then you'd also need to make sure that you were firing events for that collection. All right, so you iterate this until you're done, and then it would be wise to go take a look at everything you've got, and if it's a sleeve, pull it out separately, but make sure that they're all in that directory, or you're going to have bad physics response. Make sure your physics materials are set correctly. In this case, this pin is a different material, and so it wasn't showing. Okay, they all have the posts. All the pins have pegs, and we said this was a sleeve, and so then let's make it a sleeve. Okay, and all the sleeves have sleeves. Okay, so those are set up. we can sort of see, oh, I guess, the other thing I would do is the walls that you add across the stretch rubber bands, maybe make those also part of that layer 11. So you can see all the places where the ball is colliding with those, and you can double check them by turning off 10. You just want to make sure you're thorough, because you start removing things and then things don't work out so well. Okay, so we need one timer added, and this timer is going to be called rdampen. And interval of 10, it's going to be enabled. Okay, so that's running whenever something gets hit, whenever the rubbers get hit, and then we need to add some scripting. So from wherever you are viewing this, you want to get the file that is called rubber functions, and you're going to copy and paste that. And then you're going to get the file that's called core tracker, and you're going to copy and paste that. So that should be all we need to do on Taxi. I mean, just finish it up. But to get the rubber dampeners working, just make sure that your physics materials, match the tutorial as well. You can't just do that and then skip the rest and expect it to play well. But if you change this to the recommended values, I think it's gonna right out of the gate, you're gonna be like 85-90% improved, and then there's places you can tweak and adjust your table slope and play field friction up and down a little bit, from here. One thing you might find that's a little different as far as layout is like in a JP Salas table. He already separates out the post from the rubber band, which is nice when he sets up his tables, but it doesn't have the rubber dampening in. So you want to make sure that you add the rubber dampeners to get his tables to play nice, and of course, again, to change those values to the recommended amount. He's been doing like the low friction thing that Word and Roth had done for a while, and it gives you a better side-to-side motion with the ball, but the ball still behaves just crazy off of posts and gives you a lot of weird spin too. So these values with the nFozzy scripting are going to get you like just so dialed in right off the bat. So anyway, that's all I got. I hope that's helpful. Let me know what wasn't helpful or what I didn't cover, and we'll get it covered. Thanks.